Hey everyone! In this video, we will talk about the significance of ionic compounds as a solute and how they dissolve in polar solvents like water, and what it means when we calculate concentration of solute versus solvent versus solution. As we learned in Unit 1, ionic compounds are a pure substance that is made of two or more elements in which the electrons have been transferred from one element to another. The compound consists of positive ions called cations and anions that are negatively charged, and these ions are held together by ion-ion attraction, which is the strongest interparticle force that exists between molecules and atoms. Now let's look at what happens when an ionic compound such as sodium chloride is dissolved in water. Let's say I have a grain of salt, which is added to a beaker of water. Let's look at molecularly what happens in terms for the solute to dissolve in the solvent. Now, remember, an ionic compound consists of the positive cation, which is the sodium in this case, and also the negative anion, which is the chloride, and the two ions are held together very tightly. Now, remember from Unit 1, we know that water is a polar molecule because of two reasons. First reason being that the water is a bent or a V shape because of the Vesper formula, AX2E2, of the two lone pairs that's on the oxygen atom. And the second reason is that there's a dipole moment in which the oxygen is slightly more negative and the hydrogen is slightly more positive because oxygen has a higher electronegativity compared to hydrogen. So, because of this, water is polar. And the slightly positive and slightly negative poles of water can interact with the positive and negative ions that's in sodium chloride. If you wish the solute to dissolve in a certain solvent, there has to be an interparticle attraction that exists between the solute particles and the solvent particles. Looking at the sodium cation, it is positively charged. What that means is when it's surrounded with water particles, the water particles will orient themselves so that the negative, slightly negative oxygen will be facing towards the sodium cation. Now, when you have water particles surrounding the entire sodium ion, this process is called hydration. The same thing can happen with the chloride ion, only now that it is opposite because chloride is negatively charged. The slightly positive end of water, which is the hydrogens, will be oriented towards the chloride. Again, you have hydration of the chloride ion when the water particles surround it. When the negative and positive ions separate because it has been hydrated, we call this process dissociation. Okay, so we say that the sodium chloride dissociates in water, and the sodium chloride solution then contains free-floating sodium and chloride ions. And because there are free-floating positive and negative ions in this solution, we say that ionic compounds make really good electrolytes. An electrolyte is just a solution that can conduct electricity. Now, sodium chloride is an easy example because in this ionic compound, for every one sodium ion, there's one chloride ion that's attracted to it on all directions. but sometimes you can have ionic compounds that have more than one cation or more than one anion. For example, let's look at calcium chloride. If this compound dissociates, what happens is that the calcium dissociates into a 2+ ion, and the 2 chloride ions will be released, and they're 1 negative each. You can also have a compound where it has a polyatomic ion. For example, if I have ammonium phosphate, this is made up of 2 polyatomic ions. When this dissociates, you will get 3 ammonium cations that are 1 positive each, and you'll also get 1 phosphate anion, which is 3 negative in charge. Now, let's look at what it means when we look at a calculation called concentration. When you calculate the concentration of a solution, what you're looking at is the amount of solute in relationship to the amount of solution that you have. So let's look back at our sodium chloride example. Let's say I have 10 grams of sodium chloride. And I put this 10 grams of sodium chloride in a beaker of 100 mils of water. Now, because the sodium chloride fully dissociates in the water, it disappears completely and you won't be able to see the ionic compound anymore. Because water has a density of 1 gram per milliliter, 100 mils of water is equal to 100 grams. So here I have is my sodium chloride solution. You cannot see the sodium nor the chloride ions because they have dissociated and they're invisible to the naked eye. We will have 100 mils of solution, but the mass of this solution would be the mass of the salt, which is 10 grams, plus the mass of the water, which is 100 grams. So this gives me 110 grams of solution. There are a couple of ways to express concentration. The easiest way to express the concentration of a solution is to express a mass percentage. What this means is I'm taking the mass of the solute divided by the mass of the solution, and I multiply it by 100%. So in the case of our sodium chloride solution, remember I added 10 grams of salt. When I add it to 100 grams of water, I get a total of 110 grams of solution. When I multiply through, this would be a 9.09% mass over mass salt solution. The second way you can express concentration is you can take the mass of solute and you calculate the percentage in terms of the volume of the solution in milliliters. So the mass of the solute that we have, remember we had 10 grams of salt. And in this case, we are trying to get a percentage of that mass in terms of the total volume. And same thing, you would multiply by 100% to get the percentage. So 10 grams of salt divided by 100 mils of water, and then you would multiply that by 100, you would get a mass volume percent of 10%. In some solutions, you can calculate the percent of volume over volume. However, because sodium chloride is a solid, we don't really know the volume. So we don't use volume for this type of solution. But you can use the volume percent if you have, for example, vinegar and water solution where the solute and the solvent is both liquid. Mass volume, mass, and volume percentage are useful when you're trying to measure and create the solutions in the lab situation. But it doesn't really tell you how much sodium chloride solute you have in terms of particles. So the concentration calculation that we tend to use a lot in terms of stoichiometry is we use something called the molarity. The molarity of the solution has the symbol C. And what you do to calculate the molarity of the solution is you take the mole of solute and you divide it by the volume of the solution in liters. This will give you a concentration that has the unit moles per liter, which we also write in terms of big M. So let's try to calculate the molarity of a solution. Remember, we added 10 grams of sodium chloride, and I added that to 100 milliliters of water. How do I know how many moles of sodium chloride is in 10 grams? We've done this calculation in Unit 3. When we calculate the mole of a substance, we take the mass of the substance and we divide it by the molar mass. So in this case, because we have 10 grams of salt, we are going to divide it by the molar mass of salt, which is 58.44 grams per mole. If I carry through with this calculation, I will get that I have 0.1711157 moles of sodium chloride in 10 grams of salt. With this number in mind, I can now calculate the molarity. Calculate the molarity, I need to take the moles of solute, which I calculated there already, 0.1711157 moles, and I have to divide that by the volume of the solution, which is 100 milliliters. Since molarity is in units of moles per liter, I have to convert 100 mils into liters, which is equal to 0.100 liters. If I carry through my calculation, I will get that the molarity is 1.71 moles per liter, or 1.71 molar. What does that mean? Therefore, if I dissolve 10 grams of sodium chloride in 100 mils of water, the molarity of the solution would be 1.71 moles per liter. Now, let's say I have the same solution, which is 10 grams of salt, NaCl, dissolved in 100 milliliters of water. Let's say I add another 100 mils of water, and this brings my total concentration. This would bring my total volume of solution to 200 milliliters. What do you think will happen to the molarity of the solution? Will it increase or decrease? We can actually calculate because remember, I've only added more solution, but the amount of solute didn't change. So using our equation from before, I can calculate the concentration is equal to the mole of the solute divided by the volume of the solution. We've calculated above that in 10 grams of sodium chloride, This is 0.1711157 moles of solute. But now, instead of having 0.1 liters, I have 0.2 liters because I've added more solvent. If I carry through the calculation, I will get that the molarity is now 0.856 moles per liter, or 0.856 molar. Compared to before, remember it was 1.71 before, this molarity now is lower because I've added more water for the same amount of solute. When you do a dilution, you can calculate the new concentration or the new volume if you assume the amount of solute doesn't change. In your concentrate or your stock, the amount of solute can be calculated if you take the concentration of the concentrate multiplied by the volume of the concentrate. In your dilute solution, the mole of solute is calculated with the same formula. The concentration of the dilute solution multiplied by the volume of the dilute solution. Now, because you did not add more salt, the only thing you're changing is the volume of the liquid by adding water, you can equate the two moles of the solute. Then this gives you the equation Cc times Vc equals to Cd times Vd. If you know 3 of the 4 variables, you can rearrange the equation to calculate the last one. Let's look at a new example so we can use this equation and put it into practice. Let's say I have 500 milliliters of a 2.0 molar of a magnesium nitrate solution. Looking at my ions, how come there are more nitrate ions compared to the magnesium ions? If you look at the chemical formula, you will see because magnesium has a charge of 2+, it will attract to 2 -1 nitrate ions. That's why in the solution, I would have more nitrate ions compared to magnesium ions. Let's say I've spilled water by accident. I've added water to my solutions, so now that the solution is brought up to 750 mils. My solution would no longer be 2 molar because I've diluted it. Let's calculate the new concentration of the solution. Which of the variables would we be solving in this question? I know the original concentration is 2 molar. And I also know the original volume is 500 milliliters, which is the same as 0.500 liters. I also know that I've diluted the solution with water, so my new volume is 750 mils or 0.750 liters. So what I'm really solving for is the new concentration. So the new concentration, or the concentration of the dilute, it's equal to the concentration of the stock solution multiplied by the volume of the stock solution divided by the volume of the dilute solution. Plugging in my numbers, I'm going to have 2.0 molar multiplied by 0.500 liters divided by 0.750 liters. This gives me a new concentration of 1.3 molar. So when I've diluted my 2 molar solution, 500 mils to 750 mils, the new concentration of the solution would be 1.3 molar. I hope you understand the video. If you have any questions, don't hesitate to come ask me, either in class or after school. Good luck!